Hello and welcome to anyone tuning in to our video on differentiation for IB Math HL. In this video, we'll be going over 6 questions that help apply knowledge to exam-style questions. So, without further ado, let's begin with the first question. Question 1. Find dy over dx of f of x is equal to 2 to the power of x squared minus 5x. First, we'll begin by doing a simple differentiation of f of x. Because we can't differentiate equations like this directly, this problem would be solved through implicit differentiation, meaning to differentiate both sides of the equation. First, we want to get rid of the x squared minus 5x in the exponent of 2, so we'll take the ln of both sides to make the left-hand side ln y, and the right-hand side of the bracket of x squared minus 5x all multiplied by ln 2, as we know the identity ln a to the power of b is equal to b times ln a. The next step is to differentiate the equality with respect to y, hence taking the d dx of the two sides. This will allow us to have d dx is equal to 2x minus 5 ln 2. We want to know the value of dy dx, so we will have to multiply both sides by y to isolate dy dx. This gets us y times 2x minus 5 ln 2. Many students drop their final mark here because this is not the final answer. Because we want the answer to be equal in terms of x and constants. We know that the value of y is equal to 2 to the power of x squared minus 5x. So, the final step of this question is to substitute the value of y for that value. Then, we have the final answer of 2 to the power of x squared minus 5x times 2x minus 5 ln 2. At first glance, this question was difficult because we needed to be aware of the fact that we have to conduct implicit differentiation to solve. Additionally, we had to substitute the value of y at the end of the question for full marks. Question 2. At 0 o'clock, ship A leaves port P. It sails in the direction 30 degrees east of north at 12 kilometers per hour. At the same time, ship B is 100 kilometers due east of P and is sailing at 8 kilometers per hour towards P. Part A. Show that the distance d between the two ships is given by dt is equal to the square root of 304t squared minus 2,800t plus 10,000 kilometers, where t is the number of hours after departure. We know that the distance between A and P is 12t kilometers, meaning that the distance is 12 kilometers times the number of hours taken. Similarly, the distance between B to P in terms of t is 100 minus 8t, because the initial distance between the 2 points is 100, and the distance between the two is decreasing by a rate of 8 kilometers per hour. In the diagram, what we are looking for is the distance between A and B, which we call this d, when it is the minimum. While ship A is moving away from point P, ship B is moving closer to point P, and the ships are at a minimum distance at a certain time t. By now, many of you should have noticed that this problem is all about related rates. The first thing we want to do in these questions is find an expression of the thing we're looking for, in this case d. We'll use the cosine rule to determine the value of d in terms of t, as it is shown here. And by simplifying the expression, we get to know that d is equal to the square root of 304t squared minus 2,800t plus 10,000. So that was what section A was asking us to do. Now, moving on to part B, we want to know when d is minimum. In other words, we can simply find when the value of d squared is at the minimum, because we see here that d is just the square root of d squared. We have seen earlier that the value of d is equal to the square root of 304t squared minus 2,800t plus 10,000. And we want to know when the value of d squared is at a minimum. So, d squared dt is equal to 0. And now we want to know when this value becomes 0, because we know that the x-intercepts of the original equation's first differentiated equation is the minimum or maximum value of the original equation. This is when t is equal to 4.61 hours. We'll draw a sign diagram, and this shows that the value is indeed the minimum value of the expression, instead of it being the maximum. By converting 4.61 hours into hours and minutes, we know that the time taken was around 4 hours and 36 minutes. Therefore, at 4 hours and 36 minutes, the ships are closest to each other. Shaft AB is 30 centimeters long and is attached to a flywheel at A. B is confined to motion along OX. The radius of the wheel is 15 centimeters, and it rotates clockwise at 100 revolutions per second. Find the rate of change in ABO when AOB is 120 degrees. So let's begin by drawing a simple diagram. We'll draw a circle with center O and a radius of OA. There will also be a straight line passing through the origin, resulting in a point B. So attached at point O, this circle rotates clockwise, and as point A moves around in a circle, the horizontal position of point B oscillates simultaneously. Because we want to know the rate of change of angle ABO, we want to make an expression of angle ABO in terms of other known values. The angle AOB is known to be 120 degrees. Therefore, the sine of angle ABO should be equal to 15 over 30 sine 120, equal to root 3 over 4. We will then find cosine ABO, which is the rate of change in the distance of OX. This turns out to be root 13 over 4. Now, going back to the equation of sine, we understand that sine ABO is equal to half sine AOB. So by deriving the equation in respect to t, we get a new equation, cosine ABO dABO over dt is equal to half cosine AOB dAOB over dt. We do this because we can then substitute our known dAOB over dt value of 200 pi back into the equation, along with cosine ABO, which we found earlier to be root 13 over 4. Hence, by rearranging the equation, we can find the derivative of angle ABO to be half cosine 120 times 200 pi times 4 over root 13. The final answer is negative 200 pi over root 13. Question 4. The illustrated circle has equation x squared plus y minus 3 squared is equal to 4. Find the volume of the torus generated by removing the circle through 2 pi about the x-axis. This question provides the equation of a circle and requires us to give the volume of a torus, a donut shape, created as a result of the circle rotated about the x-axis. The first approach that must be made for this question is to break the equation of the circle up into two components, one for the upper half of the circle and one for the lower half of the circle. This question can be solved by finding the volume created by rotating the upper half of the circle, then subtracting the volume created by rotating the lower half of the circle. The domain for this circle is 2 to negative 2, so the domain for the integration must be 2 to negative 2. Now, by expanding the expression to integrate, we end up with 13 plus 6 square root 4 minus x squared minus x squared. By looking at the expression, we can see that there is a x squared term inside of the square root. Thus, it is sensible for us to substitute a trig function as x. Here, 2 sine theta would be chosen in order to eliminate the square root and find an expression in terms of theta. Finally, the substitution can be rearranged to find theta in terms of x, and this can be substituted into theta to create a new expression. Now, the substitution with 2 can be subtracted with the substitution with negative 2, which gives us the result. We end up with a volume of 24 pi squared units cubed, which is the volume of the torus. Question 5. Find the total area enclosed by the function y is equal to f of x and the x-axis for a function of x to the power of 4 minus 5x squared plus 4. Since the question requires the total area enclosed by the function and the x-axis to be deduced, the function and its roots need to be determined first. By using guess and check, the factor x minus 1 can be determined, and the factorizing can be proceeded further, giving x minus 1, x plus 1, and x minus 2, and x plus 2. Now, given that there are 4 roots, it can be said that there are 3 separate areas enclosed by the function and the x-axis. Therefore, the function can be integrated in the domain -2 to -1, -1 to 1, and 1 to 2, and can be added to find the area. However, since 2 of the areas are under the x-axis, the negative area must be taken for 2 of the areas and added up. As an addition of the area, the total area is determined to be 8. Question 6. Find the integral of 1 over square root x plus cube root x dx using the substitution u is equal to x to the power of 1 over 6. This is a simple integration question with substitution. The substitution is provided by the question, and thus it only requires the substitution to be correctly done. One thing to keep in mind is to ensure that the substitution is implicitly derived, and finding an expression for dx in terms of du. Another thing that has to be done in this question is to make sure another substitution to integrate the expression u to the power of 5 divided by u to the power of 2 times u plus 1. By letting u plus 1 equal v, the integration can be made much simpler as seen in the video. Once the integration is done, the substitution must be resubstituted, and by doing some basic algebra, the overall answer can be determined. Make sure not to forget the plus c at the end as well. And there we have it, 6 exam-style questions on derivatives for IB Math HL. If you found this video helpful, please feel free to check out our other videos on our channel. Thank you, and we'll see you next time.